Frameworks. COBIT and COSO are frameworks that provide guidance on what an organization needs to achieve its goals. These frameworks focus on establishing and maintaining effective controls over financial reporting and IT governance. Examples of goals that COBIT and COSO address include ensuring data accuracy and integrity, protecting confidential information, and minimizing the risk of fraud. On the other hand, ITIL, the Information Technology Infrastructure Library, is a framework that focuses on how an organization can achieve the goals identified by COBIT and COSO. ITIL provides guidance on best practices for managing IT services, including service design, service transition, service operation, and continual service improvement. Examples of ITIL practices include incident management, problem management, change management, and service level management. Due care and due diligence. Due care refers to the concept of doing what is right and what a prudent person would do in each situation. This involves taking responsible steps to ensure that sensitive information is protected and that security measures are in place. An example of due care would be regularly reviewing and updating access controls to ensure that only authorized personnel have access to sensitive data. Due diligence, on the other hand, refers to the ongoing effort to maintain due care. This involves regularly reviewing and testing security measures to ensure that they are effective and up to date. An example of due diligence would be regularly conducting security audits to identify vulnerabilities and address them before they can be exploited. Policies. A security policy is a mandatory document that outlines the scope of security needed by an organization. This document defines the security measures that the organization must take to protect its assets, including sensitive data and intellectual property. An example of a security policy would be a document that outlines the organization's password policy, including requirements for password length and complexity, as well as instructions on how to change passwords and how frequently they should be changed. Standards, baseline, guidelines, procedures. Standards are mandatory requirements that an organization must comply with to ensure the security of its assets. These requirements are often based on best practices and industry standards, and failure to comply with them may result in legal or regulatory consequences. An example of security standards would be a requirement to use encryption for all sensitive data in transit and at rest. A baseline is the minimum level of security that an organization must implement to protect its assets. Baselines are often established by security standards and are the foundation upon which more robust security measures can be built. An example of a baseline would be a requirement to use firewalls and antivirus software on all devices connected to the organization's network. Guidelines. Guidelines are optional recommendations on how to implement security standards and baselines. They provide additional context and best practice for implementing security measures effectively. Guidelines are often tailored to specific industries or type of organizations and may be updated as new threats emerge. An example of a security guideline would be a recommendation to use multi-factor authentication for all accounts, even if it is not required by the organization's security standard. Procedure are step-by-step documents that outline the specific actions that should be taken to maintain the integrity of the business. These documents are often used to guide employees through routine or complex tasks and ensure that they are completed consistently and accurately. An example of a security procedure would be a document outlining the steps to be taken in the event of a security breach, including who to notify and how to contain the damage. Threat modeling. Threat modeling is a security process that involves identifying, categorizing, and analyzing potential threats to a system or product. The process is typically used to identify security vulnerabilities before they can be exploited by attackers. Threat modeling can be proactive, taking place during the design and development phase of a product, or reactive, taking place after the product has been deployed. The goal of threat modeling is twofold: to reduce the number of security-related design and coding defects, and to minimize the security of any remaining defects. By identifying potential threats and vulnerabilities early in the development process, security teams can take steps to mitigate or eliminate these risks before they can be exploited by attackers. Examples of threat modeling techniques include data flow diagrams, attack trees, and threat modeling checklists. These tools can be used to systematically identify potential threats and vulnerabilities, categorize them by severity and likelihood of exploitation, and develop strategies to mitigate or eliminate them. Threat modeling can be applied to a wide range of systems and products, including software appliances, hardware devices, and network infrastructure.
Stride model. The Stride model is a security framework designed by Microsoft that is designed to help organizations consider a range of potential compromise concerns. The framework provides a systematic approach for identifying and addressing potential security threats and vulnerabilities. STRIDE stands for spoofing, tampering, repudiation, information disclosure, denial of service, and elevation of privileges. These are 6 categories of potential security threats that the model is designed to address. By considering each of these categories, the security team can develop a comprehensive understanding of potential risk to a system or application and develop strategies to mitigate or eliminate these risks. The STRIDE model is often used in combination with other security frameworks and methodologies, such as threat modeling, risk assessment, and vulnerability scanning. By leveraging these tools and techniques, organizations can identify and address potential security threats before they can be exploited by attackers, helping to ensure the security and integrity of their system and data. DREAD model. The DREAD model is a risk assessment framework designed to provide a flexible rating solution that is based on the answers to 5 main questions. The framework is used to assess the potential security risk and vulnerabilities and to prioritize the remediation of these risks based on their potential impact on the organization. The 5 main questions that DREAD model considers are: first, damage potential. What is the potential impact of a vulnerability or threat? How severe can the damage be? Second, reproducibility. How easy is it for an attacker to reproduce the exploit or vulnerability? Is it difficult or trivial task? 3. Exploitability. How easy is it for an attacker to exploit the vulnerability or threat? Is it a straightforward or complex process? 4. Affected users. How many users or systems are affected by the vulnerability or threat? Is it small or large? And 5. Discoverability. How easy is it for an attacker to discover the vulnerability or threat? Is it well known or more obscure one? By answering these questions and assigning scores for each category, security teams can develop a comprehensive understanding of the potential risk and vulnerabilities facing their organization. They can then use this information to prioritize remediation efforts, focusing on the most severe and impactful threats first. Examples of how DREAD models can be used include assessing the severity of vulnerability in a software application, evaluating the risk associated with new technology implementations, or identifying potential threats to a network infrastructure. By using the DREAD model, security teams can take a systematic and data-driven approach to risk assessment, helping to ensure that the organization is prepared to respond effectively to potential security threats. PASTA. The process for attack simulation and a threat analysis, PASTA, is a threat modeling methodology used to identify and evaluate potential security threats and vulnerabilities within an organization, IT infrastructure, and applications. It provides a systematic approach to analyze components such as architecture, data flows, and dependencies to identify weaknesses and risk. The PASTA methodology involves several stages, including understanding the business objective and constraints, assessing the application of systems, identifying potential threats and vulnerabilities, analyzing the likelihood and potential impact of identified risk, simulating potential attacks, and reporting risk to relevant stakeholders. PASTA can be used in a variety of scenarios, such as assessing the security risks associated with a new software application, evaluating vulnerabilities in a network infrastructure, or identifying potential threats to a cloud based platform. By using PASTA, organizations can take a structured and comprehensive approach to threat modeling and risk assessment, which can help ensure the protection of systems and data against potential security threats. Supply chain risk management. The risk management of supply chain involves identifying, assessing, and mitigating risks associated with various entities involved in production and distribution of products and services. In most cases, computer, devices, networks, and systems are not built by a singular entity, and supply chain risk management aims to ensure that all involved entities are compliant and secure. The risk management process for supply chain typically involves several stages, including on site assessment. This stage involves conducting an on site inspection of facilities of the entity involved in the supply chain. For example, if a company is purchasing hardware from a third party manufacturer, an outside assessment would be involving visiting the manufacturer's facility to assess their security protocols. Second, documenting, exchange, and review. This stage involves exchanging and reviewing documentation between entities in supply chain to ensure compliance with regulation and standards. For example, if a company is purchasing software from a third-party vendor, they would review the vendor's security policies and procedures to ensure they align with the company's own policies. Third, process policy review. This stage involves reviewing the processes and policies of entities involved in supply chain to ensure they are compliant and secure. For example, if a company is outsourcing a service to a third party provider, they would review the provider's policies and procedures related to the data protection and privacy. Fourth, third party audit. This stage involves conducting an independent audit of entities involved in supply chain to ensure compliance with regulation and standards. For example, if a company is outsourcing its cloud infrastructure to a third party provider, they would hire an independent auditor to assess the provider's security controls and compliance with regulations. By following these stages, companies can manage and mitigate risk associated with their supply chain, ensuring the security and compliance of their product and services.
Understanding security terms. Asset valuation is the process of determining the value of an asset, such as a piece of software, a server, or a network component. This value is used to determine the appropriate level of protections that should be applied to an asset to mitigate risk. Risk is the likelihood that a threat will exploit a vulnerability in an asset, leading to a negative impact. For example, a company's website may be at risk of a DDoS attack, which could result in the website being unavailable to users. A threat is anything that has the potential to harm an asset. For example, an attacker who gains access to a company's network may pose a threat to security of the company's data. Vulnerability refers to a weakness or lack of safeguards that could be exploited by a threat. For example, an outdated software version that is vulnerable to a known exploit could be exploited by an attacker to gain unauthorized access to a system. Exploit refers to an instance of a compromise, where a vulnerability has been successfully exploited by a threat. For example, an attacker who successfully exploits a vulnerability in a web application may be able to gain access to sensitive data. By understanding the value of an asset, the likelihood and impact of risk, and the potential threats and vulnerabilities, organizations can prioritize their security efforts and implement appropriate safeguards to protect their assets. Calculating SLE and ALE. So the acronym SLE stands for Single Loss Expectancy, which is calculated by multiplying the asset value, AV, by the exposure factor, EF. The annual rate of occurrence, ARO, represents the estimated frequency of a specific threat occurring in any given year. To calculate the annual loss expectancy, ALE, you need to multiply the SLE by the ARO. Okay? Here's an example. Let's say a company has an asset with a AV of $10,000. So it's worth, asset value is $10,000. The EF of a potential threat, right? So the exposure of a potential threat is 50%. So that exposure factor is 50%. Now, if a threat occurs, it will result in a loss of $5,000, right? So half of 10,000 is 5,000. And in order to calculate this, if you had to, it would be 0.5 times 10,000, which when you do the multiplication, it'll come out to 5,000. Now, the annual rate of occurrence for this threat is estimated to be 4 times per year. That means that this will occur 4 times within a year. Therefore, the SLE, single loss expectancy, is $5,000 for one instance that occurs. And the ALE is $20,000, right? So if it's one instance that it occurs, $5,000, 5,000 times 4 equals 20,000. This means that on average, the company can expect to lose $20,000 per year due to this threat. Types of risk. Residual risk is the amount of risk that remains after a risk response has been implemented. For example, a company may implement a security control to reduce the risk of a successful phishing attack, but some residual risk may remain due to the possibility of a sophisticated attacker circumventing the control. Total risk refers to the amount of risk that exists before any safeguards are implemented to mitigate the risk. For example, a company may identify the risk of a data breach due to weak password policies and determine the total risk of a successful attack to be high. Secondary risk refers to a risk event that arises as a result of a risk response. For example, a company may implement a new security measure to address a specific risk, but this measure may introduce new risk that was not previously identified. A fallback plan, also known as Plan B, is a backup plan that is put in place in case the primary risk response fails or is not effective. For example, a company may have a primary security control in place to prevent unauthorized access to a system, but also have fallback plans in place in case the primary control is breached. A workaround is an unplanned response that is used to address a risk or issue that was not previously identified, or when the planned risk response does not work as expected. For example, a company may have a plan to implement a new security control to address a specific risk, but if the control is not yet available, they may have to implement a temporary workaround until the control is in place. Risk management. Risk assessment is the process of identifying assets, threats, and vulnerabilities in order to evaluate the level of risk they pose to an organization. This assessment can be done using either quantitative or qualitative methods. Quantitative risk assessments involve assessing a monetary value to each asset, threat, and vulnerability, and using mathematical calculations to determine the level of risk. For example, a company may use a quantitative risk assessment to determine the financial impact of a data breach by calculating the potential cost of lost data, damage to reputation, or legal fees. Qualitative risk assessment involves assessing the level of risk based on experience and expert opinions. This can be done using various techniques, such as the DEPAHI technique, where a group of experts provide their opinions on the likelihood and impact of various risks, and these opinions are aggregated to determine the level of risk. For example, a company may use a qualitative risk assessment to evaluate the risk of a cyber attack by consulting with a group of cybersecurity experts to determine the likelihood and potential impact of various attack scenarios. Risk management continued. Risk analysis is a process of determining the value of potential risks to an organization. This can be done by calculating the annual loss expectancy, ALE, and the single loss expectancy, SLE, of each risk. The ALE is the estimated value of the loss that would occur in a year due to a particular risk. It is calculated by multiplying the SLE by the annual rate of occurrence, ARO, of the risk. For example, if the SLE of a risk is 10,000 and the ARO is 0.1, meaning the risk occurs once every 10 years, then the ALE would be 1,000 per year. The SLE is the estimated value of loss that would occur from a single instance of the risk. For example, the SLE of a data breach might be estimated costs of investigating and repairing the breach, as well as any fines or legal fees incurred as a result of the breach. By calculating the ALE and SLE of each risk, organizations can prioritize their risk management efforts and allocate resources accordingly. Risk management continued. Risk mitigation is a process of responding to identified risk in order to reduce their impact or likelihood. This can involve a variety of strategies depending on the nature and severity of the risk. Example of risk mitigation strategies include risk avoidance, avoiding the risk entirely by not engaging in the activity that presents the risk. For example, a company might choose not to store sensitive data on a particular cloud platform if that platform has a history of security breaches. Second is risk reduction, reducing the likelihood or impact of risk. For example, a company might implement multi-factor authentication to reduce the risk of unauthorized access to sensitive data. Third, risk transfer, transferring the risk to another party. For example, a company might purchase cyber insurance to transfer the financial risk of a data breach to an insurance company. Fourth, risk acceptance. Accepting the risk is an unavoidable part of doing business. For example, a company might accept the risk of a certain level of customer data exposure in order to provide a more user-friendly online experience. By implementing risk mitigation strategies, organizations can reduce their overall risk exposure and improve their ability to respond to potential threats. Risk management continued. Risk monitoring is the ongoing process of identifying and assessing potential risks to an organization and its assets. It's important to understand risk is not a one-time event, but rather a continuous process that requires ongoing monitoring and assessment. Example of risk monitoring activities include regular vulnerability scans, conducting regular vulnerability scans of an organization's network to identify potential weaknesses or vulnerabilities that could be exploited by attackers. Continuous security monitoring, implementing security monitoring tools that provide real-time alerts of suspicious activities on an organization's network or systems. Threat intelligence gathering, gathering information about emerging threats and vulnerabilities that could impact an organization's security posture. Regular risk assessments, conducting a regular risk assessment to identify new or changing risks that could impact an organization's security posture. By engaging in ongoing risk monitoring activities, organizations can stay vigilant and proactive in their approach to security, reducing the likelihood of a successful attack and minimizing the impact of a security incident that do occur.